I'm Anil Kumar. We are working with trigonometric identities including compound angles. In this video, I'm going to answer a very critical question, and that is, we all know that cos 2x is equal to what? Cos 2x can be written in a couple of ways. One is you could write this as cos square x minus sine square x, correct? It could be written as 2 cos square x minus 1, and it can also be written as 1 minus 2 sine square x. Now always in our mind we have one question. Whenever there is cos 2x involved, which formula to use, right? That's $1 million question for us. So I've taken two examples where we will actually show when to use which formula. So the first one here is cos 2x plus 1 divided by sine 2x equals to cotangent x. The second one is 1 minus cos 2x divided by sine 2x is tan x. So let us see which formula to apply where and why. Let's analyze the very first one. So the left side here is cos 2x plus 1. You get the idea. So which one should I use? If I use 2 cos square x minus 1 instead of cos 2x, then minus 1 plus 1 becomes 0. So this is the most effective formula to be applied. Do you see that? So here we will use this particular formula. Correct? So applying this formula for cos 2x, which is 2 cos square x minus 1, see how this left side gets simplified. So instead of cos 2x, I'm going to write 2 cos square x minus 1, and I have plus 1 already there, divided by sine 2x. Sine 2x is one formula, which is 2 sine x cos x. Correct. Now we can write the left side as 2 cos square x divided by 2 sine x cos x. Perfect. Now as you can see, so first we did cos 2x with this formula. Now 1 and 1 became 0. Now we can cancel out. Do you see that part? What are you left with? You're left with cos x divided by sine x, which is indeed cotangent x, or the right side. Is that okay? Now that is how you have to apply cos 2x in the correct way. Perfect. Now let's see the next example. We have 1 minus cos 2x, correct? Now in this case it is cos 2x on the other side, so take away 1. So this is a better formula to apply here. We'll see how. So we'll again start with the left side. So left side will be equal to 1 minus, instead of cos 2x, I'm writing 1 minus 2 sine square x, and we have divided by sine 2x. What do we get? When you open this bracket, 1 minus 1 is 0. And then you get 2 sine square x. Do you get the idea? So which formula to apply is very critical. Very critical. Let me write 2 sine 2x as 2 sine x cos x. Now again, as you can see, 2 and 2 cancels, sine square x cancels with sine x. You get sine x in the numerator and cos x in the denominator, which is indeed tan x. That is the right side. So in both cases we proved left side equals to right side, and that's the way to prove your trigonometric identities. But more important here is to understand which amongst these formulas for cos 2x should be applied and when. Well, if the situation is not like this, then my suggestion is apply the first formula, cos square x minus sine square x, because that can be factored. Remember, this could be factored, and cos square x minus sine square x could be written as, let me write that down also and give you another formula for here, which is cos x plus sine x times cos x minus sine x. So the difference of squares could be factored, and that is why at times this is the most useful formula. So if you have 1 involved in it, then see which one to use to cancel the 1. Otherwise, use difference of squares. That is the key which we understand from this particular video, and I hope you appreciate it. I'm Anil Kumar. Subscribe and learn more. Thank you and all the best.